Is Anji in the call by any chance? Any organizer in the call? No one, I think. And who's triggering the recording? Anybody? Amul, Deepak, Srinivas, are you guys triggering the recording or?
No, no, I haven't. Oh, so
Okay.
somebody has already triggered, right? Maybe organizer.
Mm, not sure. That's fine. I mean, yeah, the recording is fine, but just want to know, is there any coordinator in our call? Okay, fine. Mm, yet we're still waiting for the other guy to join, but that's fine. So we are exploring the control tower module. So yesterday we have seen that control tower is more for an end user, where okay, Abhinav has arrived. Hey, Abhinav, you there?
Yeah, I'm here. Sorry for the delay.
Yeah, sure. Let us know, guys. I mean, otherwise, if you're joining late, just drop a message to the meeting coordinator. Okay.
Sure, I
Thanks.
got confused. I thought it was like 9:30. Sorry about that.
Oh, sorry for that. Yeah, well, I mean, we shifted to 7:30 to accommodate for.
Sure.
Yeah, sure. Yeah. So we are just recapping on what we have done yesterday. So we are further exploring the control tower module, and so we talked about it. We have seen that they are end user related stuff. He can create an analytic chart or a dashboard or an alert on the fly, but he or she has to reuse the elements that are already been configured. So for example, like key figures and planning levels and etc etc. um, and then the data also that is there, that is populated already, either by an interface or by some kind of a calculation that's happening inside, or maybe it's output of any forecasting or any optimization run, and etc etc. So we have seen analytic charts and then different futures in analytic charts, how we can plot different kinds of charts, a heat map and a pie, bar charts and etc. We have seen how we can group by a key figure, so that it groups by, and as we go on, guys, we'll explore more this analytic app. Means like whenever, like for example, supply planning results, how we can effectively analyze the supply planning results, and we'll definitely use the analytics app and plot different things, and we can verify it. So in the last session also, I mean, not in the last, I mean in the last batch, so there were these scenarios that we can create in the supply planning thing. For example, um, if you have two options of, uh, like there is a demand and you're unable to meet the demand, and you have two options with you, either to go for external procurement, go to the co-packer or third party vendor, let him do the manufacturing for you, let him ship the stuff to you so that you can further ship it back to a DC, to a warehouse, and finally to the customer. So that is one option. Second option is to do overtime and identify some plans and do overtime, and obviously that will incur extra cost, because this labor time and etc, the resource utilization and stuff. So you will incur different kinds of costs. So you have two scenarios, uh, and you create two scenarios, and two scenarios will have different kind of costs that you incur. And then if you want to what's the best way to take a decision, whether to go for external procurement or whether to go for in-house thing with an extra overtime. So, and then if you have also configured the cost key figures properly, you can see its effect on the costs, your entire supply chain costs. And this time, at this moment, the analytics app comes in handy, where you can plot the chart for scenarios also. It's not just for key figures, but you can plot the chart for scenarios. We'll see it once we get into the supply planning module. So I'll plot my costs on two different scenarios. Scenario one, external procurement. Scenario two, in-house production with overtime, and you see different costs. And then maybe then it becomes easier for the planner to take a right call at the right moment. So analytic app will come in handy. We'll explore it furthermore, but we have seen how to create a chart, different kinds of charts, drill downs. User can effectively navigate between the charts by drilling it down from a brand level to a SKU level, and from a customer channel to customer, or etc. And when we are drilling it down, we can see different visualizations, that it doesn't have to be a bar chart all the time. And we have seen the customizations that we can do with the analytic chart, changing the colors, changing the legend, and all sorts of stuff. And we can navigate from Excel sheet to from analytic chart to an Excel interface, and etc. Specifically, yesterday we have seen the dashboards, how we can create dashboards, and how we can map different charts into one dashboard, and how uh, so we have seen how to different options available in every resizing, and navigating to analytics app directly. Like if you have five charts that are mapped to one dashboard, and you click on third chart, you can further go to the analytics app to do more analysis there, etc. And then we have also seen the filtering options, how filtering options comes in handy. Like if you have five charts that are plotted, like for example, let's say you plotted a dashboard for your supply chain costs. There is this production costs, then there are transportation costs, and there are this inventory holding costs, storage costs, so many costs, and you have plotted different charts for all these costs. And if you want to filter down, just put a filter on SKU1, and everything gets filtered. All the charts that are there will get filtered, and you can see you can just verify on that particular product across the charts in your dashboard. So we have seen filtering options. Okay, and then we went into the third topic of the control tower module. So first here we create a definition, to an alert, right? And then we subscribed to that alert. And then once the alert is, once you subscribed it, and once there are alerts, so you can see how many alerts are there as per the definition that I have set. So you can go and see the mm, alerts overview. So based on the severity that you mentioned, whether it's a high, severe, low, or a medium, a bar chart would be displayed with the number. So you can click on that number. It will further navigate to the detailed view, that where all there is an alert as per the definition that you have set. And then you can alerts overview. You see the number of alerts that are there, and then you can monitor the alerts. So yesterday here we have seen monitor alerts. We have snoozed some alerts, and then we can navigate back to the Excel sheet from that alert, or to analytics app. We'll see more details, that where exactly is this alert, again based on the definition that we have set, and the system would display the information as per what we have defined in the alert. We want to see the weekly buckets, or whether we want to what all key figures we want to see along with the alert data, and etc. And then there is another concept called alerting to action. So this is one, alerting to action. We have seen this. This is more like case management, I would say. Come on. case management. So here we can pick up an alert and we can create a case, and then while creating a case, we give we can assign a owner to a case. So yesterday we have seen that there is a deviation. The alert we defined is a deviation. There is a high deviation for a particular combination, for a particular product ID, and for a particular customer. So I assigned an owner and I created a case, and then so that would be visible in another app called Manage Cases. So there the whoever gets assigned a case, yeah, he will see some cases there, with the details, and he can go and he can give some comments. It would be stored in that case, and everyone can see. So this way you can increase the collaboration and transparency between the teams. um, he can go and close the case, and basically he can further assign it to another team, and etc etc. And if there is a jam in place, there's this thing called jam, social media for an enterprise. If we have jam, then we can extend this functionalities to a different level, but unfortunately I don't have the jam access. So and yeah, I mean, not I have worked in 4 implementations end to end. So the only one project has opted for jam. Other 3 projects, they didn't opt it for jam because jam comes with a different license. So it's kind of a social media platform for the businesses, where the jam can talk to S4 system or Ariba or Success Factors or IBP. I mean, basically it can talk to anything. So but whereas in IBP in specific, from Excel sheet we can post the data onto the jam tool in the jam group, and it's on cloud. So it's like a kind of a Facebook. You create a group, like for in this example, maybe a marketing team has 5 people. They all are in that group. It's on cloud, can be accessible through their mobile phones. There is an alert. He can post the data into the group so that others can view, put a like, share, comment, add more data, add some another content. They can add these Excel planning views in it, and then they can create some polls. And I mean, imagine like what all is available in Facebook and another LinkedIn kind of a thing. Everything is there in that jam, and yeah, it helps them for further more collaboration, etc. But still, even inside the managed cases, there is a facility that the planners can give a textual comments, and not just the numbers, but they can actually leave a comment, and you can save it, and then we can actually take some action on the alert. So the control tower is not just stopping and just giving you an alert. I mean, it's not stopping there. We can further take it up to another level. So alerting is there. There is a definition. There is an alert. But you can snooze it, or that's it. That's the max that other applications can do. But IBB, took it another level. So, so today we'll spend some time briefly on something called as a machine learning option that is there in the in the in the what in the alert definition itself. So yeah, I mean, this thing is still evolving. The machine learning. This is one of the uh, what this is one of the priority for SAP to make IBP robust in machine learning algorithms also. So it's still evolving. Um, Maybe by 2020 we can expect more robustness, more consistency in this machine learning thing. But having said all that, there are few options available in the alerts. We'll see them. So but before that, so I'm inside this planning view. um, I'm viewing a key figure called as the sales forecast quantity for the products from the NIDC 101, SIDC 101, two DCs connected to the Amazon, connected to Best Buy, Chroma, Flipkart, etc. So let me put a filter on just the Amazon. So I'm just putting some kind of a conditional formatting just to show it to you guys that, you know. Okay, so just kept a conditional formatting on it, a simple conditional formatting on the entire sheet. I mean, if you have observed, I just reuse the standard Excel functionality called conditional formatting. But this is not on template. I mean, this is just for our analysis. I mean, the moment not sure if I click on refresh, will it go or not? Let's see. Yeah, it is gone, because once you do a refresh, what's happening is that, let's read the stuff that is mentioned there. Refresh the planning without saving key figures. Okay, whatever. So I mean, this is not giving the right picture, but the moment you click on refresh, what happens is, based on the config that is there on this Excel planning view, all these EPM functions, etc., system goes to the backend, fetches the updated values and puts it onto the system. So once it puts it on the system, it obviously follows the formatting technique that you have used in the EPM formatting. So in the EPM formatting for the sales forecast quantity, there is some kind of a, the formatting, it might have mentioned, then it is displaying as per it. So whatever ad hoc changes that you made, they'll get lost. So now I'm showing it to you that, so the forecast was like kind of hundreds, but there are few places where I have some kind of different values, just three places. Hmm? If I minimize it. Okay, there are just three cells here. There's one cell, three cells. 5,000, 900, 9,000. So what do we call these? Outliers, maybe. Yeah. So now if you want to know these outliers, what all options we have? So with the standard alerting, I mean, let's just say that, the entire objective is to alert the user that there are some outliers in it. How to identify this? So um, mm, when you're doing a forecasting, that's a different story. There is this option to data cleanse. While in the data cleansing, you delete your outliers, and then kind of normalize your history and then use it for your forecasting. But that is not that what we're talking about here. So we have, let's just say, this is not even sales forecast key figure. Let's just say that these are some kind of a production plan. So we are viewing a production plan for different SKUs on different bombs inside different production facilities, and you have some plan, and but there are some outliers. How to identify them? Machine learning algorithms comes in handy in here. So there are two algorithms that are available. So now I'm going inside now inside define and subscribe to alerts. I'm creating an alert just to identify these three places. Okay, and then we'll say it. So outliers in sales forecast. Um, just config. Okay, version is base version. Calculation level, the sales forecast, where exactly it is. It was at a week, product, and customer. So I mean, it need not be at that level. It could be at any level that we want. Means for that particular I mean, you cannot write here that I want to do it at resource level, or maybe ship from location level, I mean, shipping location level, or you cannot use some kind of a source ID level. Source ID means a BOM number, production version. So if you say that, then it will obviously throw an error, because you're trying to plot an alert for sales forecast. So that is at a week, product, location customer. But now within this planning level, you can pick up any aggregate attribute. For example, inside product, you can pick up brand or product family, etc. Inside customer ID, you can pick up customer region, etc. Or you can just pick up customer ID itself. Then system does the aggregation, and then you can um, yeah, system does the aggregation and calculates the whatever the rule that you mentioned here, and then it will display the alert accordingly. Product ID, location ID, customer ID. Like what I'm saying is that you can uh, have an alert at monthly level. You can say that month, you say calculation level is month, and then you write a definition that my sales forecast is greater than 10,000. Save it. Now what system does is, instead of looking at a weekly value, which is 100, it will does the aggregation for a month. So for it, these 4 weeks constitute the month of June. What is the total sum? The total sum is less than 10,000. No alert. If any month, if the total aggregated value is greater than 10,000, an alert would be coming. So that's what I'm saying. That is what the calculation level means. Time horizon weekly from, I'll pick up the current bucket.
Hey Venkat, quick question. So the calculation level that you gave, does it calculate at each and every of that level, or is it like consolidated?
Yeah, for every unique combination, right?
So does it calculate at customer level, or does it calculate at customer product location level?
Based on what I gave here,
Correct.
yeah, it calculates at every unique combination of week, product, location, customer group.
Okay.
I don't know why I gave customer group, but customer ID. Severity, just give medium. Now alert rule here, I'm not giving any alert rule, so just to make it simple. So there's no alert rule here. So I mean, I can give an alert rule that if sales forecast is null or not null, or if it is greater than this much, if it is greater than 150% of another key figure, blah blah blah. But I'm not doing all that. I'm getting onto the machine learning rules. I'm picking up DB scan. The moment I picked up the DB scan, it is giving me it's asking me three important things. So so it is asking me the key figure where the DB scan has to be applied on, and then it is asking for the attributes for what all attributes you want to uh, um, have you guys heard about the DB scan algorithm by any chance? Okay, just go to Google, type DB scan. This is not a statistics class, so unfortunately, I cannot, take you in detail about the DB scan. It's a data clustering algorithm, very very old. It is available in all, um, you know, uh, um, what do you call, all the programming languages as a standalone algorithm. That is, it is available, and it's available in R, the software called R. Wherever you do the statistics, this it comes in handy. So a lot of content is available, guys. So I'll just this is a nice example, I would say, easily to explain. So what it exactly does. So it's a data clustering, so it clusters the entire data. So here we said that pick up the sales forecast, and I said this is it. What is it said? It's at weak customer. So it picks up the weak customer, and then it looks at all the data, and then it clusters it into small chunks, and it clusters based on the its relativeness. Like here, all the values are 100, 100, 100. So they all will be cluttered into one small group, and there are these outliers 5,900, 9,000. So they would be spread at a different places. So those are the outliers. So I think if I go here, so you see, so this is how it clutters. So you see all the red ones, they all are related. Maybe they are 110, 120, 125, 130, 145. They all, the distance between every data point, so I think they use a different language for it. They won't say it's a distance, they call it as mu, I think. I'm not sure what is the standard. Whatever. So all this 10, 120, 130, 105, etc., they all will be cluttered. And there is another value called, 555. So that was like way above. So maybe that 555 might come in somewhere in here. And there are other values like 5,520, 5,525, 5,500, 5,650, 5,755. And then there's another value called 9,000. So that would somewhere go in here. So you're getting right. So this is just outlet detection to put it in this thing. So you give the key figure at the level at which you want to identify the outlets. So that's it. And then choose automatic. If you say manual, then it further brings you the different clustering methods. Clustering means it kind of forms a group in the entire data set, and then a minimum number of points you want to put it in a cluster, and what is the radius between in the cluster, number of threads, the category weight, and what is the distance method. So distance means distance between, see here in this, distance between this point and this point and this point. So all these are kind of the C, B, A, C. So they all are like uh, in kind of, they are equidistant. The distance between those two is kind of closer. They are reachable, but whereas this n, this is an outlier. This was way up, way outside. This is neither close to this point, not to this point, or to any point in all these 1 2 3 4 5 6 7. There are 7 red dots and 2 yellow dots, and this blue one is not close to anything, so that means it's an outlier. So here is 500, 900, 9,000 outliers. Okay. Yeah, where were we? So yeah, pick up all this. So if by luck, if you in your implementations, if the client wants to explore on DB scan, then good for you. You can go back to Google and start learning more about statistics, and also you can go to YouTube. There are a lot of videos available on the DB scan. It's kind of a famous thing. And there is another thing called k means. So k means means it's another clustering algorithm, but this will not go by will not go by attribute. So here means I gave the customer for the DB scan. So for every unique combination of customer, it forms a clusters. Okay, but whereas with the k means, so you cannot actually segment them based on the customer. So it just takes all the available data that is there. So here, if Amazon, you have all these hundreds. Let's say there is another customer called eBay. There are other sales forecasts, and then there's another customer, Target store. There are other forecasts. So they are in 300. eBay is at 500s. It takes that entire data as one single kind of a segment, and then it applies the data clustering on it. But whereas with the DB scan, you can segment it accordingly. So you have to give the segment. So you have to say that for every week and then for every customer. Okay. So what do you want to see? This is metrics. I mean, now we're done with the machine learning rules. Metrics is what metrics you want to see when there is an alert. So I want to see my sales forecast. You can also say that if you want to analyze not just the sales forecast, there are other key figures. Let's say there's key figure X, key figure Y, which are ultimately getting summed up or averaging that out, and then the average of XY is getting onto sales forecast. So in that case, you can also bring up the key figure X and key figure Y to analyze those source key figures along with the calculated key figure that is a sales forecast quantity. So what I'm trying to say is metrics, you can bring out the key figures that you want to see. Okay, and then the display options, unit of measure is EA. There is no currency. Default chart type is like bar. That's fine. I'm subscribing to it. What is the name that we gave? Back to the 1 second. What is the name that we gave? Forgot. Maybe outlier. Description filters. Yes, I'll put one filter on just customer ID. Amazon. Display options, sharing, back to the, click on this, back to the definition, click on save. Okay, this is saved. So now if I go to my custom alerts overview, okay, it's in medium severity that we gave, coming as 3. Then click on 3, and with what all places this alert is there. Yeah, you see it is showing 5,000, 900, and 9,000. Week 32, Galaxy M10, DC101, customer ID is Amazon. Week 37, week 41. So those are the weeks: week 32, week 37, week 41 in those cases. So I just gave 100 guys. I mean, you might say that, why will we have 100 across? So I should have maintained this for 1 year. So it needs, obviously it needs a lot of data. So if we have enough data, then then you can actually give arbitrary data like 100, 110, 120, 130, etc., and then it would work accordingly. But I didn't maintain the, it needs for, it needs more data. So if you don't have the right data, then that that's what, right? I mean, the quality of the data is obviously very, very, very important in this case. So majority of the times, why in my implementations, why they didn't go on for the machine learning rules is that the data itself is the quality and the quantity of the data, the both are important. You need high data, and then you also need the quality data. So then the system will come up with some results, and it will show it to you. But here it is straightforward. All are like hundreds, and 3 outliers, 5,900 and 9,000. So here it is clear. But in some cases, it actually gives you kind of a tricky things, and in that cases you need to go to the manual and pick up uh, come on. Yeah, so what I'm saying is that instead of automatic, you need to go for manual, and then maybe play with what if it is a hard clustering, how it will have an impact on my outlier detection, etc. So yeah, so that would be kind of a big homework, and some kind of a good learning exercise for us if we really get this requirement in our way. Okay. So yeah, that's all about the this thing, about the usage of machine learning rules, and especially to identify the outliers in your key figure data.
Venkat, so yesterday's plotting, right? So yesterday we also saw the algorithms and others,
Sorry.
and today machine learning. So what is the difference?
Yeah. So what is the difference? You see here in the alert. I'll show it to you. So a normal alert is, you apply an alert based on a definition. So that means you go. Come on. So there would be rules. I'll tell you some alerts. If the capacity utilization is greater than 90% alert, so then I want to be notified in my production facilities. Or so in that case, I'll go and I'll say that my capacity. 1 second. Capacity utilization is greater than or equal to 90%, then alert. Sometimes these 90s keep on changing. So the planners, they want to maintain the threshold in a different key figure. Then in that case, we'll go with the percentage, and then we'll say some kind of a threshold. There is a capacity. threshold, yeah, so minimum capacity threshold, some kind of a threshold values. And then now you can say that if this is if this is greater than this much, then have an alert. Or if my projected stocks are less than my inventory targets, I want to have an alert. And yesterday we have seen one thing. If my consensus demand is greater than 120% of my some other statistical forecast. So that means the stat forecast has ran its algorithm, maybe linear regression, moving average, whatever it is. It gave some value, and then you did some adjustments, some promotions, etc., etc., and you finally came up with some other demand, final demand. So now you want to see how well I have deviated my final forecast with my statistical forecasting. You just want to be alerted so that you can go and take an action that why there is a huge deviation, so etc. So these alerts will pop up when the business is going on in the go live. So sometimes suddenly a user might think that, okay, now I want to compare key figure X, key figure Y. There is this mathematical calculation: if this is X is greater than Y, or if X is not equal to Y, or if X is less than Y, etc., etc., they can use an alert. But whereas machine learning algorithms, they are more in identifying the outliers itself. So now with this rule group, with these mathematical calculations, you cannot identify this 5,900, 9,000. There is no way. How can we, it's kind of, it's really impossible to identify with this. So here you can either compare your key figure with an absolute value, absolute here, and then you say give some 10,000, etc. Number one. Number two, either you can compare two different key figures, give an alert. But whereas with the machine learning algorithms, inside the key figure itself, you have a huge data with you, and in that huge data, there are some outliers. Uh, and then you want to identify those outliers, then machine learning algorithm comes in. So plot it and then just be notified with those outliers. So that's the kind of difference between a simple custom alert and then
Uh,
this finding outliers. Yes.
Now in this example, right? So it's like pretty straight. Like we have almost 99% of hundreds,
Hmm.
and
Hmm.
only three are the outliers.
Yes.
So what is the case? So if we have let's say 100 cells, and
Hmm.
100 cells has 100 different quantities.
Huh. Exactly. So
So
that's what I'm saying. Out of those 100 different quantities, the so that's what I explained to you guys, right? So this is what. So you have 100 values. Everything would be plotted like this clusters. So out of those hundreds, you have, let's say, you have three different data sets. So some are varying between 100 to 500, 100, 110, 110, 150, 120, 150, 160, etc. There are other kind of data points that you have between 111 and 2333. Okay, within that 100 cells, you're saying 100 data points, weeks and products and locations and customers. There's other data point like 555 and to 888. Let's just say that somehow by randomly they are between these three things and these three. So whatever that are there between this, so this could be one clutter, and all these things would form a small circle kind of a thing here. I mean, this is not visible obviously, so this is kind of a graphical representation of how the algorithm will work in the backend. So you have all this, and then here also you have all this. So now if you have a value like 777, something like that, only one value. So now this is outlier where this 777 is neither fitting with this cluster not this cluster, not this cluster, then this is an outlier. So that is what that is how the machine learning works, and it gives you an alert that there is a value called 777 at a particular level, that this is at this, for this customer, this location, this week, there's a value called 777, because that is not, this is not fitting in any of the clusters. So there are some clusters which are within a range of 100 to 500, some clusters within 1111233333. So that's what here it is showing here. So 3 clusters, blue ones, green ones, red ones. There are these gray things which are kind of outliers because they are not fitting in that cluster. That means the distance between those data points is high. So here also you can see that the center point is green, so the red ones are going out, then that means that's why they are kind of outliers. So here also you can see that between every cell, the distance is kind of this can be mapped. So the distance between 100 and 110 is 10, 110 to 120 is 10. Now 110 to 450 is kind of huge, but 450 to 480 is 30, 450 to 500 is 50. So it could be like 450 might come here, 480 might come here, 110 might come here. So that means they all can be mapped and they all can be formed as a cluster. So now I become a statistician. Good. So yeah, so that is how the the clustering would work. Just give it a try once you get the system, but make sure that you load enough data, huge data. So to make things simple, no, I just give it as a kind of a straightforward. So otherwise I would have loaded like at least 6 months of data for different combinations. Then you run it, then you see it will give you an alert. It will definitely say that you know so that is the thing with the forecasting algorithms, right? Even if you use like a complex algorithm like arima algorithm or etc, double exponential smoothing, it will give you a forecast. It's up to us as a consultants that we have to interpret it, that why the value is like that, why the forecasts are 100 and now there is 150. What is impacting this 500? Is it the alpha value that I maintain, or is it the beta, or is it the the error measures that I should have considered, etc. So just like that, if I maintain a huge data set, it might give an alert on 33333. It says that this is outlier. Now you need to go back to the system again and then analyze your data, and then you have to finally build up a right configuration here so that the users can pick it up and start using it. Yeah, hope it helped. But yeah, this is still evolving. Even SAP is cooking up some content to be visible in their help and in their forums on these machine learning algorithms, like how we can the same is happening in S4 world also. So in S4 also they are trying to bring up a lot of machine learning rules, and so so yeah, we can expect more content and more um, more knowledge will be shared by SAP itself on these machine learning things. Okay, so yeah, so the other topic of the day is now from tomorrow, guys, we'll start the configuration. So we'll get into the system. But before that, I just want to give you some theory on the entire planning area and the elements that are available inside that planning area. Okay, so when we go with the configuration, so there is this 4-step cycle that we have to follow. First is we have to define our model. So we have to create attributes like product ID, brand, product family, etc. And then we have to specify what is the data type, whether it's a varchar. They are like characteristics in APO. Sort of varchar, numeric, date, timestamp, or etc. You have to create master data types. There are different master data that are available. To create master data, create time profiles. You have to create a planning area, and you have to extend all this stuff to a planning area. To create planning levels by using the master data types, assign these planning levels to a key figure, write down the calculations for the key figure if there are any calculations, create versions, etc. So you have to define your model, and that model will have a status that is called inactive. Then the second step is you have to activate it. So once you activate it, system checks the integrity of it, and it creates, I mean, it checks all the you know calculations that you wrote, and how you have created master data, how they are extended to a planning level and further to a key figure, etc., etc. And it checks all the integrity, and if they all are accurate, it creates some tables and procedures and permissions backend, and then finally the planning area is active. So once it is active, the database will be created for all the key figures master data. Then you can import data into that model. So that means if you create a master data called product master data, and you set the product ID, brand, product family, etc. are created, then you can load the data. So how you load the data, that's a different thing. Um, um, Interfaces, flat file upload, or directly manually entering the values through Excel sheet. Data integration jobs, we will see them. So then you can load, like, product ID is this Galaxy smartwatch, family is a smartwatch, brand is Galaxy, and etc. You can maintain all those and then load that file, or load that into the master data, and finally you use it. So just like the way we're using it now, so we're plotting different charts and alerts on the key figures that has already been configured. So we'll follow this 4 step, and then we'll create a planning area, and then we'll do it from the scratch in our session only. We'll start creating attributes, assign them to a master data, etc. Okay, so now how that entire mapping is done, so I'll just show it to you. Just created some kind of nice animation for myself. So now there are these attributes. You say that attribute is called something called product family, and there is something called product group, and there is something called brand, etc. You create all those attributes, and actually, see, we don't have to create all this because this has already been there inside the planning area. So the first step is, you take a copy of a planning area. uh, uh, Usually we take a copy of a unified planning area. It's with the name of SAP IBP 1. So once you take a copy of it, so all these master data are already there. The attributes are there, the key figures are there. There are some standard 400 odd key figures are there. They're already been configured. So the calculations are already there for it. For example, a key figure called capacity utilization. So there is a calculation that is already written. So the calculation is that available capacity divided by how much is being used. That's it. So available is 168 hours in a week. The resource is available 24/7 all days in a week, and then you utilized 100 hours. So 168 by 100 gives you, or is it the other way around? Whatever. The calculations are already there for some key figures. But when you are implementing, there would be requirements, custom requirements. Users will need more key figures, and then maybe on the capacity utilization itself, they want to take that utilization, and then they want to do something on it, like they want to take a snapshot of those, and then use the capacity utilization in calculating some other key figure, etc., etc. So you have to create those inside that um, that planning area. Or the product master data has standard attributes of 19. It's all available inside the system, but the requirement is that they want another custom attribute for the product master data, where they can they want to do some reporting on, for example, uh, mm, is something called product level. Let's just say some other hierarchy in the entire product master data. So then you have to create a Z attribute, and then you have to follow this entire procedure. first define that attribute, extend that attribute to the planning area and other places, and then activate and then import values to that new Z attribute, that is product level, and then start using that product level attribute in all your Excel reporting alerts wherever it is. Okay, we'll see that. We'll go there. So first, I'm saying first we'll create some attributes, or or let's do one thing. So the scenario that we'll be taking is mm, so there are some master data that are already available. So I think once we get into the supply planning, we'll see all the existing master data that are there. Um, yeah, tomorrow also, we'll spend some time to we'll see what are the master data that are already available that comes in handy, the standard master data. But so our for our a training purpose, so I'll take a custom scenario, and the scenario name is maintenance planning. uh, Maintenance planning. So why do we want to plan maintenance? I mean, you can plan anything. IBP is a planning system. You can plan your human resources. And so I'm in my first project, we did the human resource thing. So but that was for a strategic planning. Um, it's a utility company. So the use case was that they want to know that you know um, they try different kind of strategic options, that to shut down a plant, and to open a new plant, and to merge two different plants and make as one plant. So every plant requires this much of these many plant managers, this much of labor, and etc etc. So they wanted to just see the impact of taking these supply chain decisions and how it will impact on your human resourcing. So what was their existing strength? And so that this is not like operational plan, right? I mean, that was more like a strategic plan. So they'll have a 5 years of data. It's a water industry. um, so there is something called Met Office. It's a global weather reporting system. So it does a lot of weather forecasting. It gives you 5 years of forecast, future 5 years, how the water levels are going to be, etc. So they want to take that data and they want to give some optimizer runs, and they want to see how we can meet that demand, and whether we have to go with extra capacity, start new plants, shut down old plants. Sorry for that. So yeah, so if you take those kind of decisions, and how it will have impact on the cascading effect on your entire organization. So one pain area they thought is a human resource planning, and they want to see the impact of those decisions onto this human resources. So how do we build up these master datas, and how we create the key figures at the human resource level, and then map them to a plant capacities, blah blah blah. Consultant comes into the picture. So yeah, the whole point is that you can do any kind of a planning inside IBP. Okay. But for now, we'll take the maintenance planning. um,
Hey Venkat,
hey, yeah, who's that?
this is Abhinav. Quick question.
Hey, hi, Abhinav.
So,
Yes, sure.
I just heard about human resource planning that you were telling. Just a quick question. So traditionally, if we look at the APO space, it is majorly driven totally by manufacturing companies. So
Hmm.
when you talk about human resource planning, is there a different benefit with IBP? Can it do something more than what we traditionally do with APO? Because I have not heard human resource planning in APO, so that's the reason I'm asking: is IBP capable of doing that level of
No, no,
different
no, no,
planning?
no, 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 no. No, no, no. I'm sorry for that. So, sorry to highlight on that. So, IBP has a standard feature. Nothing is there on the human resource planning. So, but what IBP allows you is to you can create custom master datas, you can create custom attributes, you can create
Okay,
custom key figures. So whatever we can achieve it in an Excel sheets. So all these planners, they do a lot of Excel things, right? I mean, they'll see different values and a lot of calculations, and they transform from one level to other level. So all those things can be replicated in the IBP system.
got it.
So yeah, so in human resource planning is also not a major pain area for them. So it's just like a few data points, there's some calculations that if I do that, what is an impact, just a directional thing. So I just want to know that I need to go for extra 50% of new hires, etc. So that was just a custom thing that we did. It's not a standard feature, and we also told that this is not the right way to do it. So I mean, obviously, there are other things that you have to worry about, like success factor, etc. But why they didn't went into that level is because here you are taking a supply decision, increasing your plant capacity, shutting down a capacity, etc. That was more like a supply decision, and it will have its impact on different things, your costs, your stocking positions, etc. And also they also want to see the human resourcing thing. There are these standard mappings that are there, that this plant, category A plant requires 5 managers, 10 labor, etc., etc. They just want to do a simple mathematical multiplication, that then give some value, that so that's it. So
Got it.
no major decisions has been made on that. So yeah,
Okay.
cool, thanks for that. So
Thank
maintenance planning, yes, so there is this QM module, PM module. There are other standard SAP modules, and then why you're reinventing the wheel. So I mean, I'm just saying that here we'll not go to that activity level. We create a work order, and then we say that okay, now you go and do this, shutdown activity, this and that. Nope. So here what we're doing is maintenance planning. Um, you have a demand, you want to run your supply will give you the supply plan, how much to produce, how much to ship, how much to procure, etc. But to produce, the major input is the capacity. The capacity decides your production. But every plant, let's say that they go through a lot of maintenance activities. So that maintenance activity obviously requires the plant to shut down, or maybe it will consume some of the capacity. So they want to have a visibility of the maintenance activity that is happening, and how much of the capacity will get lost by this maintenance activity. And they want to see that what is the final available capacity, which my supply planning algorithm can consider. So this is the entire scheme of things. So is something called maintenance ID. Let's just say that maintenance job 101, maintenance job 102, and then the description is chemical cleaning, and then maybe dry vacuum services. Let's say in your plan you are you have to do all this stuff, so you have to clean your mm, resources and etc. And then maintenance job, just following some kind of a naming convention, or maybe this is a sorry, some shutdown activity or something like that. So so um so you I want to create a master data, like so I want to do this maintenance planning. So I'll see all this chemical planning, dry vacuum services, shutdown activity, and there are so many other maintenance jobs that I will do inside my plants. And as a maintenance planner, I'll go and specify that which activity will happen on what time bucket in what plant. Okay, for example, This is week 40 of 2019. This is week 42 of 2019. This is week 43 of 2000. Right? This is week 44 of 2019. So there is this um, northeast plant is there. So there is a key figure called capacity supply. No, I mean, let's say there is a standard capacity, standard available capacity. Oh, come on. For this plant called any plant 101. Okay. Um, let's say there is a resource called maybe robotic assembler. There is one assembler. It's a robotic assembler, and then it is available for 168 hours. So 168 hours on week 42, 168 hours on week 43, 168 hours on week 44. Available 24 by 7, 7 days a week. So now inside this any plant 101 on this resource called robotic assembler, if a chemical planning happens, chemical cleansing happens, that activity will, as a planner, I'll just go and say that okay, on week 41 I'll do chemical cleansing, and it has to go with the dry vacuum services. They both should go hand in hand. Maybe you have to do chemical cleaning and give it for some time, and then do a dry vacuum services. And also say that, as a planner, I'll just go and give a flag that I'll just say that one. So that means one signifying that I want that activity to happen. Okay, so if I say one, then system has to understand that inside this location, this plant 101, on this robotic assembler, chemical cleansing dry vacuum will happen. And then what is the capacity that it consumes to perform this activity? So to do chemical cleaning on robotic assembler, it takes minimum of 10 hours. And dry vacuum services, it takes 20 hours. So if both are happening on week 41, so my final available capacity has to be, let's say 10 and 10, 20. So your available capacity is 148. Okay, so you guys are getting me? Hey, you guys are getting me or not?
Yeah, Venkat.
Cool, got it. So now here comes the catch. So is it the same like 10 hours like for every maintenance activity irrespective of the resources and locations? Nope. The complexity comes in here. If it is a manual assembler, it takes more time. Okay, so it is not 10 hours, but it is actually 25 hours in case of manual assembler. Okay, let's say this is robotic assembler 101. Again, is it just the type of the assembler that matters here? Nope. It is also the plant that comes into the picture. Maybe plant 101 is so big, it was widespread across. The assembling line is so big, it's almost a 500-meter long, let's just say. In plant 102, the assembling line is very small. But it's a robotic assembler 201, let's just say. But it is not that big, and then obviously the maintenance activity will not take 10 hours. It will just take 5 hours, so etc etc. So there are these combinations where the maintenance activity, the duration that it takes, let's say there's a duration, there's an attribute called duration, duration of the activity duration, something like that. We'll create an attribute, z attribute, activity duration. And then also this attribute, activity duration, it shouldn't be in this master data. Why? Because I need more visibility to actually deduce my activity duration. So I need another dimension, a dimension of location, a dimension of resource. Then I can rightly map my activity duration. So that means so this is plant 101 and this is our assembler 101. There is a manual assembler 101. The maintenance activity is M job 101, that means chemical cleansing 101. So here the activity duration. So here the chemical cleansing happening on robotic assembler inside plant 101, it takes 10 hours. But on manual assembler, the same activity is taking 20 hours. But in plant 201, which is considerably a smaller production facility, so the same M job 101 will take just 5 hours. So you guys are getting me right. So where I am mapping this attribute called activity duration, and it's a data type of integer. So in what master data I am maintaining it. So yeah, so we'll configure this guys from scratch. What all master data we have to create to do this maintenance planning, and we'll go there. We'll take this scenario, we'll stretch it. So it's not just I specify 1 and 0 and 1, and then we'll also we'll make it as a real-time scenario as much as possible. So we'll also maintain some thresholds here, so some kind of a minimum capacity required is, let's just say that minimum capacity is 150 hours. I need a minimum of 150 because maybe these 3 weeks we are in ending of the quarter two, maybe we need to produce more. Next week it is just a 125 is fine. So if it is 148, that means which is less than the minimum required, then I want to have an alert which is a key figure based alert. And then the planner should go and adjust this, maybe take off this and then say here 1, and now here it should become 158. um, right. So we'll do all this, and then we'll also build on this. We'll get the actuals, I mean planned maintenance activity. So the planned maintenance activity is here. Let's say this is 1. So this on this week, inside this plan 101, the plan is that 30 hours has to be get wasted, or 30 hours has to be consumed by this maintenance activity. But in reality, actual maintenance duration or whatever, that could be like 55 hours. So it is not in sync with the plan. So then we'll compare with actuals and planned versus actual, and we'll just build on that as we go ahead. So before we conclude the day, so this is what we'll do tomorrow. So first we'll create our attributes, all attributes. So tomorrow we'll also talk about this scenario in a bit more deeper, and we'll jot down all the attributes that are required, and then we'll extend them to master data types. So here if you see, where is that? Oh no, what happened? Okay, it's an Excel, right? Yeah, cool. So yeah, so here we created all these 3 attributes, custom ones, and then there's also this attribute called activity duration. But okay, this is not the one. Maybe here you can say that maintenance type. Maybe here you can say this is preventive maintenance. I'm just building up a hierarchy inside maintenance jobs so that I can do my reporting accordingly. So means I can just put a report that my planned preventive maintenance across my locations, across the jobs, how much I am going to consume the capacities, etc. So this belongs to shutdown. If you guys have anything, just think about it, guys. Tomorrow come back and let me know the use case. So okay, this is the planning that I want to do. I mean, just talk in pure business perspective, that if this is my requirement, how we can achieve it through the IBP, how I have to configure my systems, my master data, my planning levels, so that I can do my planning and come up with my values. So tomorrow we'll create all these attributes, maintenance type, etc., activity duration, and then we'll map them to different master data types. We'll activate those master data types, and then we'll have a planning area. So you see this green colored one, and then we extend these master data to a planning area master data types. And then we have a time profile. We will create time profile, and then we use both, and we create a planning level. And then using all this, we create a key figure, and then like key figures like this. What is this? So standard available capacity, final available capacity, etc. And then maybe mm, come up with a nice name. Maintenance maintenance job start period, something like that. It's kind of a flag. If I say one, that means it's going to the the job is going to start, and something like that. So we'll create all those key figures like standard available capacity, maintenance job start period, final available capacity, maintenance capacity required, minimum capacity required, blah blah blah. And then we also extend them to versions, and then we'll do our maintenance planning. Sure, any doubts?
Hey Venkat, Abhinav here.
Hey, hey Abhinav.
Venkat, a quick question. So we spoke about attributes like product ID, product family, etc. So even if we are doing supply response traditionally, like SNP, it works on product location. So do we need just two attributes, or do we still have to use all the attributes?
Means in the supply planning.
Correct.
Yeah, so I mean there are a lot of attributes which we have to, that will have an impact on the supply planning run. For example, if you take a transportation lane in IBP, we call them as location source of supply. It is constituting of three master data. So there you have your shipping location, destination location, and then the product that is been moving in. These are the three key attributes that constitutes that forms, and also mode of transport, truck, rail, or whatever. Now there is another attribute called as a lead time, and if the lead time is 3 weeks, then obviously it will have an impact on supply planning run, right? So if the demand is on current week and I cannot do a shipment, the demand is for 100, I cannot produce 100 because I require 3 weeks to ship that 100. So if the demand is on the week 4, then yes, I'll do my production on week 1. I'll start shipping on week 1. It takes 3 weeks. It will reach your location by week 5, and that's fine. So yeah, so coming back to your question, that there are attributes which will obviously impact the supply planning runs, and then inventory optimization also, it will definitely impact. There are so many attributes. Like for example, if I take the resource also, I can say whether it's a resource is a finite resource or an infinite resource. If it is an infinite, then there is no capacity restriction. Now, locations, there is something called location type. If I say location type is V, that means it's a vendor. So system thinks that okay, this is a vendor location, and it gives a different kind of a plan. So yeah, there are some attributes which will have an impact on supply planning runs, and we have to consider all those. So if there is no lead time, then system would fail. Means the lead time attribute is not there. I mean, system will not look for data in it. I mean, you don't have to maintain a lead time for all your transportation lines. You can just keep it blank. Then system thinks that okay, there is no lead time, so I can produce on the very same day. So but those attributes have to be there with a specific name. So lead time, the technical ID is LEADTIME. You have to make sure that attribute has to be there with the same technical ID. Then only the algorithm will work, the heuristic or optimizer. Now the other layer to your question. So then do I have to create all those lead time attributes and etc etc? Nope. They're already there in the system. So if you take a copy of IBP1, all the supply planning related attributes are there. Inventory optimization, they are there. So we don't have to do anything. So they all are there. So we just need to load the data properly, run our supply runs or inventory optimization runs, and see the results.
Sure. So I will definitely wait for. I'll ask you questions if I have any when you show me when we talk about those. But I was just curious, so I thought I'll still ask you.
Yeah, that's fine. Sure. And and also a supply planning run. See, there are so many attributes. Um,
I'll tell
like,
you the reason why I'm confused with the term attributes. I'm a APO
Mhm.
guy, right? So traditionally you have product master, and all these lead times and all these are values within the product master. So over here we are telling products as an attribute, location as an attribute. So I was just
Mhm.
wondering if every value within the product master, what we see in APO, is that an attribute in IBP or?
Yeah. So everything, all the brands, product families, base unit of measure, ABC indicator, etc., etc. All those are like the attributes. But based on the dimension that you're dealing in, like transportation lane dimension. So there, okay, lead time can be a part of, but how can it be a part of a product? Because the same product, uh, b- based on the shipping location, the lead time will increase, right? So definitely it shouldn't be a part of the product master data. I mean, I can say that my Galaxy smartwatch, the lead time is 5 periods, but that is depending upon from which DC I'm sending. If I'm sending from Northeast DC, it will take 10 working days. But if it is from the central DC, which is in the center of the entire geographical location, it takes only one this thing. So we need those shipping locations dimension into it. And again, take this resource type of finite resource or infinite. So that we cannot make it as a product master data attribute, because it has to be a part of the resource master data. So etc. Yes, very well, we'll go through it, Abhinav. So
Sure. Okay.
when we deal with the
I'll
supply
wait.
planning and
Sure, sure. I'll wait.
inventory optimization, all those attributes will try to deal.
I'll
So
wait.
tomorrow I think it will